Hello everyone, my name is Ilote Eric, a CIS 607 student. So the research problem I was handling was predicting car prices for an automobile car company. I had three research questions. The first question was what variables are significant in predicting car prices? The second was is the price of a four-door car different from the price of a two-door car? And lastly, what car makes are most similar? I tested and answered these questions using four techniques. The first method was a multiple regression in SPSS. The second was decision tree classification in JMP. The third was independent sample t-test in R. And lastly, k-means clustering in R. So to begin with the first question, which was what variables are significant in predicting car prices, I used two methods here. And the first method was multiple regression, and the output is as shown here. So when we look at the output, we find that it was only three variables that were significant in predicting car prices. We have the wheelbase, and then we have the compression ratio, and then the horsepower. These variables were significant at 0.05 alpha. Then the R square for the model, the regression model, was 0.775. So we can say that the model accounts for 77.5% of the variation in car prices. Then the second method to test the same question was the decision tree classification. And I chose this method because unlike regression, which is affected by multicollinearity and variance inflation factors, decision tree classification is more of non-parametric, and therefore it's not affected by these factors. And when we look at the output, we can see that the most important factor in determining the car price is the engine size. The value is 0.7558. So we can say that engine size accounts for 75.6% of the variation in car prices. The R square for the model was 93.9%, and the validation was 83.3%. Then when you move to the second question, which was, is the price of a four-door car different from the price of a two-door car? I used the independent sample or groups t-test to test and answer this question in R. And the output is here, and when we look at the p-value is 0.6576, and therefore I concluded based on this p-value that the price of a two-door car and that of a four-door car are not different. Then finally, the last question, which was what car makes are most similar. I tested and answered this question using the k-means clustering, and I chose two variables, the engine size and the price. And when we look at the clusters, we can see that cluster 1 is made up of cars that have a small engine size and their prices are lower. And then cluster 2 is made up of cars of a medium engine size and a medium price. And finally, cluster 3 is made up of cars of higher price and larger engine size. Finally, the challenges that I had. One was interpreting the cluster analysis output. I had an issue there, especially when I was including several variables. And then I had an issue with checking for multicollinearity and variance inflation factors. And then also I had an issue with identifying and modifying outliers. But I found that the decision tree classification method as the most preferred method, because the method is not affected by multicollinearity and variance inflation factors. Thank you for tuning in. There is a summary of this video down below. Remember to read it. Thank you.